Sandra, buenos días.
Buenos días. Bonjour, Claude. Comment allez-vous?
Bonjour. Hello.
Hello, how are you?
Oh, strange, you don't see me on the picture.
No, you are invisible right now.
I don't know why.
No, I don't know either.
Same setup as yesterday. Let me start again, okay?
Yes, that's right. That's fine. Hola, Andrés. Hola, Bolívar.
Buenos días, profe. ¿Cómo está?
¿Cómo estás? Si pueden, porfa, avisarles a los compañeros que ingresen. Porque como ven, el expositor ya está acá. Let's see if I can see you, Claude. Yeah, good. Now I can see you. So what was that? Do you know what happened?
Hey, you could ask Bill Gates or one of those guys.
Not you, okay. So how are you today? Thank you for being here.
We had snow yesterday, so we have again a beautiful morning with snow all over the place. It is what minus 5 about minus 5 Celsius, which is warm for us because normally we should have minus 15 or even minus 30 in this time of the year.
Oh my God! So for you, it's a good day today.
Oh, minus 5 is warm. It's like spring.
Oh my God! No, you have to come down here to see how spring is like. Here is spring all year round. So,
yes. But the thing is, we have four seasons. So if you don't like one, you can wait 3 months and you have another one, and you have another one. So we have 3 types. So the worst one regarding the way that you travel and you when you go outside is winter, because you cannot sit on a chair outside because you're going to freeze.
Yeah.
But otherwise, you do ski, you do skating, you do walk. So you keep yourself warm, because if you just stop, you're going to freeze.
Yeah, and the landscape is also beautiful. I mean, the whole thing white and the snow coming down. So I like that too. That's right. Yes. Anyways, I think we can start. So, buenos días con todos. Vamos a empezar el día de hoy con una charla especial. Como ustedes pueden ver, tenemos el día de hoy la presencia del doctor Claude Laporte, el autor del libro de texto que hemos venido utilizando y que, por cierto, hoy día ya es nuestra, digamos, terminamos con este texto y pasamos al siguiente. Así es que, bueno, nos falta todavía una persona, pero vamos a empezar y pues quisiera que aprovechemos al máximo la presencia de Claude haciendo las preguntas que ustedes deseen. En principio podemos escribirlas en el chat, en inglés o en español, y yo la puedo interrumpir a Claude durante la presentación. Y también al final de la presentación podemos tener un espacio de preguntas y respuestas directas con él. Así es que ese es el plan para el día de hoy. Let me switch to English. So Claude, welcome here. Thank you for being here in our class. As you can see, this is a very, very small class, but I'm very happy to be teaching this class because these guys here, they are studying to be software engineers, which is exactly, you know, what we want to talk about with you this morning. So anything you can tell us today, advices, information about how to be a good software engineer would be very appreciated for all of them. And since there are so few of them, I want to introduce you personally to Andrés Yomikinga, Bolívar Andrés, Ricardo Falcón, Ismael Rivas, and Brian Ortuño. So that's our auditory today, and I just leave it to you so you can introduce yourself and start with this presentation. Thank you.
Before we leave, could we set a protocol for the questions?
Yeah, you can explain them.
Okay,
I already did, but you can go ahead.
No, fine, excellent. Thank you. Thank you, Sandra. Buenos días. As you know, I am French, So I will be talking to you this morning in English. So it will be like Franglish using Spanish slides. So it is a multilingual presentation. So let me switch now to, since you saw my face, let me switch now to the presentation mode, and I will talk from that point. So we are going to discuss, and again, don't hesitate to ask questions. We have 2 hours, so don't hesitate if you have a question. Either you can wait at the end or just ask Sandra and she will interrupt me. So as I will introduce myself after introducing my university. So my university is an engineering school in Montreal with 11,000 students. And we have one specialty of our universities. Our students have to go in industry for 3 semesters, not 3 semesters in a row, but 3 semesters during their 3.5 years of training. So the university runs 12 months a year. So students can attend classes or go to one of the internships. And as you can see, for the 3 internships, they are paid about $36,000. So they're not slaves. They are working like an employee. And the name of the game is for them to put in, to apply what they have learned, and also to learn from industry, from different types of industry and different size of industry, different culture, such that eventually, when they reach the final program, final semester of their program, they better know, they know much better where they would like to work. And most probably, when they did their last internship, maybe they have already identified an employer, and maybe the employer has already made an offer for them to work. So I would say about 95% of our students in software and IT engineering, they have a job even before they graduate. Okay? So as you can see, we have about 1,400 students in software and IT engineering at the undergrad level. So about myself, I worked for the military for a few years, and I was pioneering, because in those days, back in the 1980s, the buzzword was computer science. And what I saw being a military was that the military didn't just need computer science, but they needed more, something like software engineering, because they had to maintain very huge systems, very complex systems, very critical systems. So I went to the Software Engineering Institutes many, many times. I met the directors and all the nice people of the SEI. And eventually, with the help of the SEI, we started 2 things, a software engineering center in Montreal and the first graduate master's degree program. And the first graduates graduated from the military academy in 1991. And then I went to work for aerospace, Earlycon Aerospace, and I was managing, coordinating the development of systems, software, and project management processes for this organization. So as an example, we had about 35 software engineers working in the software engineering department. And also I did some consultation with Bombardier, where I had the privilege to do some process engineering and also train software engineering, software engineers in Asia, in North America, and in Europe. And also I did some few projects with the Montreal subway. And then year 2000, so 21 years ago, I joined ETS as a professor in the software engineering department. And in year 2002, I was delegated by Canada as an expert of Canada to attend and represent Canada for software and system engineering standards. So the presentation this morning, after a quick introduction, I'll be talking about software quality assurance and see what I will be presenting to you, because there are many, many practices, see those practices as tools in a toolbox. So depending on the type of projects, depending on the size of the project, depending on the criticality of the project, you'll be selecting different tools to make sure that you'll be delivering quality software within schedule and budget. When I say you as a developer, or you as a quality assurance expert, or you as a manager, or you as a team leader, all of you have the responsibility to identify the risks of the project and select the appropriate practices to manage those risks, because all software engineering projects have risks. Some are lower, some are bigger, and also we won't have time to talk about that, but we have the known risk, the risk that you know that could materialize, and also there are the unknown risk that you never thought about, and that will be knocking at your door Friday afternoon at 6 o'clock when you're ready to go back to your home, and then you have to stay to the office and work overtime for the next 2-3 weeks to manage this risk. Okay, enough about this. I will be talking about standards for small organizations. As maybe I didn't mention it, but I am the project editor for the ISO 29110 standards of systems and software engineering standards for small organization. So small organization is either a company, or it could be a project, a department, a team having up to 25 people. So what it means is you could have a startup with 2, 3, 4, 5 people that can use 29110 standards. And you could have within a large organization, you have teams, you have departments, you have projects, and within that large organization, you could also use 29110. So we have 2 series. We have the series for software, and also we have the series for systems. But systems means in our context, it means something or a product that has both hardware and software, like your telephone, your computer. A computer is a little system by itself. And I'll be talking about the benefits of 29110 and then a conclusion. So let's go back in time. Let's go back to 1968, where the NATO people, countries of that part of NATO at a conference, and they were talking for the first time about software engineering. So a bunch of experts were talking about the software crisis. Now, when you read the list that I will present you, you might be laughing. Those are the manifestation of the crisis in the 1968. So they were just in those days, they were just starting to build computers, okay, with small programs, and even then they had to face those problems. So one of the attendees of MIT said this, and I'll let you read this sentence. Okay, so what are the challenges of a company, of a government agency? Because the challenges are similar, whether you're working for government or whether you work for a bank or whether you work for a company, challenges are similar. The priority might be different, but the challenges are similar. So they want the software to be developed faster. They want to have better quality. They want to be cheaper. And they want to have, for you and your team to be more productive. They don't want delays. They want to meet the exact schedule that has been developed or signed in the contract. They want no cost overrun, and they want to be the first on the market. So that mostly applies to a company that develop a new product, but it's roughly the same thing for our government organizations that needs a tool to perform some functions. They want it as soon as possible. But the secret is you should achieve better quality, because if you achieve, or if your objective, your primary objective is to develop software with a better quality, most probably you will be also meeting the other challenges. But if you reach as your first objective to be faster, there is a probability that the quality will go down and the price will go up. And eventually, even though you reach for faster software development, you may get late because, as I'll show you later, you will have to do a lot of rework. So what is software? you know what is software because you are software engineering students, but let me point that to you that different people having different point of view have a different definition or a comprehension about what's the meaning of the term software. So for students and professors, it's debug the code that you've done as a result of an exercise or some homework or project. And for many software developers, it's partially tested code. And for customer that will be using the software for a short time, what I mean by short time, a few weeks, a few months, maybe a year or two, they also want some documentation. But for the users, customers of software systems or software that will be used for many years, when I say many years, in those cases, it could be 10 years, 20 years, 30 years, 40 years. Okay, we have software in banks that have been developed in 1960 in COBOL, okay, that are still running. And I read an article a few days ago, or a few weeks ago, sorry, when the US government wanted to give money to their citizens, they had to modify some programs. And when they opened the box, they discovered that they had millions of lines of code written in COBOL and didn't have any more COBOL programmer around. So they were scramming, they were hiring people that were 60, 70 years old to come back for a few weeks or a few months to make the modification to the software such that they can pay, they can issue checks to their citizens. So those organizations, they want a lot of documentation because the information that was in the head of the developer has to be documented such that when those developers get promoted or change department or leave the organization, this knowledge is kept in the documentation and that will be used for the maintenance for the next 10, 20, 30, or 40 years. So this is the spectrum, I would say. If you go up on my slide, it's more computer science mindset. And as you go down on my slide, it's more software engineering mindset. So I was talking to you that some systems are used for decades. So this is an example. And as you can see, the article is dated August 12 of this year. So it's not a very old article. And you can even look on Google and you will find a nice video that explains that in more details. But what I want to show is that even in the Boeing 747 that are flying and that are about to be retired after 40 years or so, they still have 3.5 diskettes to load some programs or data in their computers, in one of their computers. So it means that they have to maintain those computers, they have to maintain the software and remove the defects for the complete life cycle of the system. So components of a project, so if we were perfect, 100% of our effort will go into the cost of execution. So developing the software, developing the plans like the project plan or the configuration management plan or the risk management plan. But as we know, we're not perfect, so we have to perform evaluation. We have to perform reviews. We have to perform testings and audits. And if we are intelligent, we'll try to learn from our mistakes by putting in place or improving the training, improving the methodology, the processes, the tools, by putting in place standards and also by gathering metrics and analyzing the data of those metrics to make intelligent decision. Because the objective of capturing metrics is to be able to use this data to make decision, wise decision about the quality, productivity, etc. But since we are making mistakes, we have to correct those mistakes. Okay? And those are what we call the cost of correction. And I call them the cost of rework because it means that you have to do again testing. So you have to do again the developing some pieces or sections of documents where you found mistakes. You have to execute again the tests, etc., etc. So my question to you will be, in the project that you've done, even if you've just done projects within academia, what will be your estimate of your percentage of rework? Okay. Any idea? Okay, so those are the 4 cost categories that I just explained. And the objective is to reduce the cost of correction, the cost of rework, ideally, in the ideal world, to 0%. But as we will see, if we get 4 or 5% of cost of rework, we are in great shape. Okay, it doesn't mean that you cannot reduce it to 2-3%, but if you ever have 5% of cost of rework, you'll be part of the nice or best organizations developing software. So if you cannot provide the data about those 4 cost categories, can you really say that you're managing a project? Okay, where's the money? Where's the effort going? Because as you'll see later on, a high percentage of effort goes into this category called cost of rework. So if you don't have any visibility on that, how can you manage, and how could you also make wise decision to improve if you are blinded on the fact that you don't know what is the percentage of rework? And the next questions that I ask to companies that claim to be producing quality software is, can you tell me what is the average density of defects injected by your organization? And I ask also, what is the average defect density detected by your organization? And what is the number of defects that you deliver to your customer? So when a company says they're developing quality software, if they cannot give me an estimate, a good estimate of those numbers, then my question to them is, if you cannot provide me with those measures, how can you say that you're developing quality software? Okay, let's be honest. If you don't have those 3 measurements, can you really say that you have a quality software? You don't have any idea, and also a quality process, okay? Because the objective of quality assurance is also to make sure that the process is of good quality, because a bad process will most probably produce bad software, okay? A good process will improve the probability of doing good quality software, providing that you have also trained, well-trained software engineers, and you have the tools, and you have the time to do what you're supposed to do. Okay, let's move on. So my question to you is, can you guess what's the percentage hidden behind that blue square or blue rectangle? So surprise, surprise, about 50% of projects is wasted in what we call rework, and avoidable rework, meaning that if we did it right, we could have avoided to waste 50% of the effort, 50% of the budget, and maybe more than 50% of the calendar. So if you want to be, look at from a different point of view, 1 out of 2 engineers is producing nothing. Okay, yeah, let's say you have 10 software engineers working on a project. So with 50% rework, it's like you have only 5 people really working. Okay, sorry. So if you don't change anything, you cannot expect the situation to improve. No, there is no miracle in software engineering. The word is engineering. So if you want to look for miracle, you have to go somewhere else. Okay, so if you have to improve the process, you have to improve the tools and do the right things for things to improve. So let's move back in time in the 1800 and let's talk about Dr. Semmelweis. And just for your reference, in those days, Louis Pasteur wasn't around yet, and the discovery of germs has not been done, just to put you in the context for my presentation. So you'll see later on why I'm opening a big parenthesis and talk about the medical domain. And you'll see that there are a lot of commonalities between the people in the medical domain and the people in the software domain. So the background, back in 1846, there were 2 maternity clinics at the Vienna hospital. One clinic, they had mother would die after giving birth to a baby, and the percentage of death was about 10%. So 1 mother out of 10 was dying of fever. And in another clinic in the same building, in the same hospital, the death rate was only 3%. And Dr. Semmelweis was hired to become the titular of the first clinic. And in those days, he says that women were begging on their knees not to be admitted to this clinic because they knew they had 10% of the chance to die in that clinic. Okay? So both clinics, as you can guess, were using very similar medical practices because giving birth to a baby, whether you are in clinic 1 or clinic 2, is the same process. Okay? That same process, and also the process that has been executed millions and millions of times before. So Semmelweis asked himself, what is the difference between clinic 1 and clinic 2? So he took some data, took some measurements. He went into the books, and he documented the fact that in the clinic where he was nominated, the percentage of death was much higher than in the other clinic. Then he started to see, he asked himself, what's the difference? Because there should be a difference. Because a factor of 3, if it happens only once in 10 years, then maybe you said it's a bad luck. But when it is systemic, then you have to find what is the item, what is the thing in that process, which make that systemic process to kill three times more women for the same giving birth process. So the only difference were in the first clinic, the people that were there were medical students, were professors, were surgeons that were teaching medical students, and the other clinic were nuns, midwives, that the only purpose of that second clinic was to give birth to babies. So my question to you is, in which clinic were more dead mothers? So intuitively, you might say, second clinic, because in the first clinic, they all the nice professors, they have the surgeons, they have the medical students, which were a lot more educated than the people from the other clinic. Yeah, that would be the intuition, right? But wrong, the answer is it's the first clinic, okay? As I told you before. So one day, some medical student, doctor, cut himself during an autopsy with a scalpel, just a little cut. Okay, like you do cut yourself with a knife when you're trying to cut some meat or something like that. So you don't lose your finger, but you just cut a little bit. And then he died a few days later. And the autopsy showed that he died with a similar situation that the women were dying in the medical clinic, in the birth clinic. So Semmelweis proposed a connection between those two cases, between that the doctor that died with the same process, same analogy, okay, and the mothers. Okay. And so the difference, one of the major difference, as you could expect, is the people in the second clinic, they were not involved in autopsies. They were not doing like the students or surgeons were doing in the first clinic, where they were doing an autopsy on one body, and then 10, 15 minutes later, they will be giving birth to a mother, and then they will go back to their autopsy, doing 1 to 3 hours of autopsy, dissecting cadavers with the scalpels, and as you can expect, a lot of blood and things like that. And then going back to the other side of the clinic and giving birth to mother. So what Semmelweis did, he says maybe there is something that is that we carry from from doing autopsies to when we touch the woman, okay? We touch the mother. So he said, let's see if there is something that we carry, maybe it's in our hands. So he instituted a policy to wash your hands, or just asking the students and the medical staff to wash their hands with a solution of chlorine. And the death rate went from 18% in April to 2% in June. So almost instantly, okay, because he instituted the policy in May, okay, and he took the data in June and it went from 18% to 2%. So you have a factor of 9, okay, between those two, between the month of April and the month of June. So normally you would have jumped into the air and they would say, hey, Eureka, we found the solution, right? The data, hey, this is what the data shows, right? The data shows that it went from 18.3 to 2.2. So the data does not lie, like some politicians try to tell us for the last 4 or 5 years. But the data says the birth rate, the death rate was divided reduced from 18 to 2%. But as soon as you insert human beings, and this you can see on this chart here, effectively you can see the death rate going from wild swings to less than 5% of patients. And also, so as Semmelweis says, maybe if there is something that we carry in our hands and when we wash our hands, that those things disappear. So maybe the same things we have been carried by the tools that we use to do surgery and things like that. So let's also wash those instruments. And the net result was that he almost eliminated the fever from the hospital. Okay. So again, you would say, gee, with this, it's foolproof. He's got the data to show that by washing your hands and by washing the tools, that you almost reduce to 0 the percentage of dead women. So it is a breakthrough. So he should receive a prize. Okay. Oh, but the thing is, in those days, the infections perception or the theory in those days, and I remind you that the theory of germ was not discovered yet, was that those diseases were being spread in bad air. There were some miasma, okay? And that was contrary to the establishment. So what Semmelweis was saying, he was saying that we are carrying those things in our hands, and the medical doctrine in those days says, no, 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 it is in the air, okay? Or those atmospheric, cosmic, terrestrial influences, okay, for whatever it means. Okay? So surgeons, which were gentlemen at the top of the society, they were saying that they were offended because they were saying, hey, you're telling us, we surgeons, we part of the medical establishment, that we have dirty hands, because you're telling us that we have to wash our hands when we touch the patients. So that doesn't work. Okay, we are gentlemen, so go away. Don't bother us with this. Okay, and the story ends dramatically because eventually Semmelweis was sent to an hospital where he died because he became full. Okay, he died because he discovered that nobody believed in what he said, even though the data proved the contrary. Okay, even though the data provided the support for what he said. So we call this the Semmelweis reflex, which is the natural human behavior to reject new knowledge because it contradicts actual norms, beliefs, or paradigms. And my question to you, and going back to software, is do you think that people involved in software, and when I say people, the managers, the developers, you as students, customers, and professors could experience the same Semmelweis reflex? Okay, I remember a few years ago, I was teaching a course in Thailand, a software quality assurance course, and even professor there at the university that I was teaching, they were surprised when I said that you could measure the software quality. They never thought that could be possible. Okay, and they were challenging me that no, you cannot. This is invisible. No, you cannot measure software quality, right? So I was talking to professors teaching to software engineering students. Okay, so in the newspaper from Boston a few years ago, there was an article talking about how bad the situation was about the fact that medical staff were not washing their hands. So you could see that a lot of people were dying, and it costed a lot of money in those days. Now, if I open another parenthesis, it's exactly what's happening right now in USA and in other countries, by the way, where many people, a high percentage, not 1%, but a high percentage of people don't believe that COVID could harm people or could bring death to people still today in many countries around the world. Okay, so nothing is changing very much, eh? So let's go on that. Let me close the parenthesis. So it says, if you improve the hand washing by a small percentage, you will have a drastic reduction in patients being infected by germs. Okay, and one hospital succeeded in having 80% compliance in the intensive care unit. So intensive care units, for your information, is where people go, the last resource. Okay, if the treatment given by the intensive care do not work, you just die. Okay? And this is, by the way, what is happening in many intensive care hospitals right now because of COVID. So they reach 80%, and 80% is not 100%, right? So there is still 1% out of 5 in very sophisticated environment. I went and visited an intensive care center in an hospital, and I can tell you this is very high tech. They have high tech instruments. They have high tech products. They are top of the notch about their competence. They have medical doctors that are experts in those cares. They have nurses, experts in intensive care. But even that, 1 out of 5 were not washing their hands when going from one patient in the intensive care to another patient in the intensive care, right? And the reason why they achieved this 80% is because of this. Okay. So by giving away free tickets to go to the movie, this is how they achieve 80%. Otherwise, they would have been below, I guess, the 50% level, like many other hospitals. Now, maybe this is one of the things that COVID is teaching most of us. I say most, not all of us, but most of us, is by washing our hands, we may be able to kill the virus. So the question to you is, are there analogies between the germs in the medical environment and the bugs in software? And I'll be talking bugs for a few minutes, and then I will not talk about bugs anymore. So, and also, are there analogies between the personal people working in medical environment and the software people? So analogies between germs and bugs. So germs are invisible to the human eyes, but germs can be seen and counted using a microscope. And it's similar for bugs. Bugs I put are not visible for many people, okay? Even though they are there. They are there in the code, or they are there in documentations, in the requirements, in the architecture. People will read the document and will not see the bugs, okay? And for your knowledge, I've been teaching software reviews for 20 years in industries and academia all over the world, and there is a factor of 10. So if I provide a document, the same document to 30 people, some people, and they have the same training, they have the same documentation, and they have all the same time and the same checklist to identify defects on one page, okay? And I personally injected 30 defects in the page. Some people will detect 3 defects, and other people will detect 30 defects. And I've seen that all over the world, a factor of 10. So this is why I say for the majority of people, the bugs are invisible. So I'm closing this parenthesis. And when you open your eyes and you know, after doing reviews, you can also count the bugs like you count germs. And also medical procedures and medical products have been developed to get rid of germs. Similarly, since the 1970s, processes, tools, practices have been developed to detect and correct defects. So we're close to the 1968 conference, the NATO conference in 1968, because we are at the beginning of the 1970s at IBM, where Michael Fagan developed the inspection process. So 1973, if my memory is right, he published the article explaining is the new software process to identify and correct defects. So 50 years ago, those technologies were around. So the way it works is we as human beings, we're not perfect, and we produce errors, okay? And those errors will be eventually become defects in documents, and defects in code, and defects in tests, and defects in different things. And those defects can produce a failure. It could be a negligible failure, like a blue screen on your PC, or it could be catastrophic failure when the brake of a subway or your car do not work because there is a software bug in it, okay? So the objective of software quality assurance and also other software engineering practices is to prevent errors and also to help you to detect errors. So we have to work on both ways. If we are intelligent, we learn how to prevent errors from being done, and we also prevent defects from being injected. And because we're not perfect, we know that we have defects, then we have to detect them. So, little parenthesis, the word bug was first used back in 1947 when the operator of a military computer, in those days they were using mechanical relays, and the computer was not performing well, so the operator went around and she discovered a bug, a mote that was stuck between the relays, and so she took that bug out. And what you see here is a photo of the logbook of the operator, and the evidence of that failure is the bug that has been scotch taped on the logbook of the operator. And so this is where the word software bugs come from. But in software engineering, we shouldn't be using the word bug, because bug is like an act of God. It's out of human control. It comes from the floor, it comes from the ceiling, it comes from the door and the window. Okay? While an error means that some human being has been doing the error. You as software engineer have to take the responsibility, because you are the one developing the software. So don't invoke the word bugs, use the word error. And by using the word error, you will become more responsible, and you will be asking yourself and other colleagues, how can we help to reduce those errors? So with bugs, you get rid of bugs with this, okay? But you don't get rid of software errors with this, okay? You may get rid of software developers that are producing bad software with RAID. That's another thing, okay? Okay, let's go to the House of Quality. So the foundation of the House of Quality. So if we move from the left to the right, we have the references on the left side with the standards, the models, the defect categories, the quality models. And as we move to the right, we have the configuration management. Configuration management roughly is the management of change, management of version, and in any project, there are changes to the needs of the customer, changes to the requirements, and changes because we made mistakes. Okay? We made mistakes and we discovered defects somewhere in the code, and you have to go back sometime in the requirements and modify the requirements and things like that. So we have reviews. Reviews, this is the most powerful tool. I say again, this is the most powerful tool to identify defects. Very easy to do. Okay, it just takes very low tech. It takes a pencil and your brain and some time and some basic training. And as you learn to identify defects, you become more efficient. And as you learn to identify defects on your products and on the products of your colleagues, then your computer in your brain should learn to inject less defect. Okay, you will have some background processor, and as you're writing code, you're writing documentation, you should be asking yourself, is it clear? Is it complete? Is it ambiguous? Those things. Okay, let's move on. You have measurements. we have verification and validation. I'll be talking about that in a few minutes. Management of supplier, the cost of quality, I'll talk about it. Cost of ethics, business models. Business model, the reason about this is each organization have different risks, different challenges. And as I said initially, based on those risks and challenges and context, they will select different quality assurance practices, different software engineering practices to minimize those risks. And also we have checklist and risk management. So when you're working on a project, you identify those practices and you document that in the software quality assurance plan. And this becomes the foundation to produce quality software, to have continuous improvement, continuous training, because as you learn from project to project, as you gather data, as you gather metrics, you improve the process, you improve the checklist, you improve the tools, you improve the methodologies, and you improve the training, okay? So you have productive and motivated employees because they know that you're producing quality software, and you have also happy customers. And to do that, you need some basic quality assurance function. When I say function, it could be 1 or 2 individuals. So if you have 2 teams of 5 developers, so one guy from team A can do some QA on team B, and one guy from team B can do some QA on team A. But if you have a bigger organization, then you could have a full-time 1 or 2 or 3 people doing QA. And if you have a bigger organization, like when I was working at Oerlikon Aerospace or Bombardier, then you have a department that's doing full-time quality assurance on their projects. And to do that, you need the strong support of management, support for the budgets, and support for the training, and support for the time to do what is required to do the things right. So let's talk about reviews. So reviews is a process, okay, a meeting. Most of the time it's a meeting where a product or a process is presented for comments, okay, for examinations and for approval. Okay, so this is basically the spectrum of reviews, and it is documented in a standard, an IEEE standard, IEEE 1028. So you don't have to reinvent the wheel. You can look at IEEE standard 1028, or you could acquire books, because there are books dedicated. I know at least 3 that have been around for 20, 30 years, books about software reviews, okay? And as you may expect, there is some chapter, there's at least 1 chapter in my book about software reviews. Now, let you read this. So it means that you're learning at an accelerated speed, okay, faster. Because as I said, you're learning from your own mistakes and you're learning from the mistakes of others. So everyone is learning. So in a very short time, you learn a lot. So I strongly encourage you to do software reviews in your projects. And the first 2 or 3 times, maybe it will not be as good, but as soon as, like anything, like cooking a new meal, using a new recipe to cook a new meal, maybe the first 2 times it will not be perfect, but after doing it 2, 3 times, 3, 4 times, you get better, you know better the process, and you become more efficient at detecting defects. So the defect detection process is similar to the analogy that I'm showing you is the treatment of river water when water comes in with many bacteria, and it is filtered with, let's say, a large filter with a large grain to remove bigger elements. And you measure, and you have smaller filters, finer filters, and much, much finer filters. And at each stage of the process, of the filtering process, you are measuring, okay, the quantity of bacteria removed, the quantity of things that was floating in the water that had been removed. And at the end, you end up with drinking water, safe drinking water, with a known number of bacteria, known because there are still some things in water, but it is safe to drink it. That our human body have been accustomed to a certain amount of bacteria. The system, our human body will fight those, and you will have no problem. So software reviews is similar. okay, at each stage of the process. As I will show you in a few minutes, you put in place filters, reviews, at least, and you measure at each step of the process the number of bacteria or number of defects identified and eventually corrected. So we have a wide spectrum of reviews. I don't have time to talk about those in this 2-hour presentation. This topic deserves a 2-hour presentation by itself. But just to be aware that, again, for the different risks, you have different tools, and the different types of review that I'm showing there are for exactly for that, to address, to identify defects from different perspectives, and also depending on the criticality of or the importance of the product that you have to review. So on this slide, you see on the bottom the life cycle stages of software development, starting with the requirements, REQ. HLD stands for high-level design. Then you have low-level design, the coding stage, unit testing, integration testing, system testing, and shipment. And on the left side, you have the defect density expressed in defects per 1,000 lines of code. K-loc means, K means 1,000, LOC means lines of code. If you use function points, then you just change the density by defects per function points. That's okay. Okay, so what you have is normally you inject, even if you don't know, you inject defect at each stage of the process. And once you reach the coding phase, after you've coded, then ideally, you don't inject new defects, ideally. And unfortunately, what most people do is they wait until they have code to detect defects. But the problem is when you detect defects, let's say in unit tests or integration testing, or even when you ship it after shipping to the customer, then if you identify that this defect is caused by a defect in the requirements, then it means that you have to go back and modify the requirements. You have to modify the architecture, modify the code. And by the way, you also have to modify the test procedures, maybe the test cases, and rerun the tests again and measure if you have to remove that defect. So all that is reworked. So my question to you is, what are the problems with this approach? The approach that I show right now on the slide. So I'll let you think about that for a few seconds. So as I just mentioned, the defects that were made earlier are detected most of the time late, because that's the only thing you use. If you go back, you detect the defects only when you do tests. So defects injected in the requirements or architecture, too bad that you don't see them. Okay, even though they're still in the documents, they will materialize to your eyes only when you do testing. Okay? And also, you're relying only on tests. You cannot detect all the defects. As soon as you have a complex software, it becomes impossible to go through all the path for, let's say, a 100,000 line software project. Okay? And the correction of defects is not perfect, because the human beings that make defects originally are roughly the same human beings that will be making the correction. So we're not perfect, so we'll still be making mistakes when we'll be correcting defects. But life is like that, okay? We're not perfect yet. And it means that we have to rework previous tasks. And if you have many defects to remove at the same time, then you may end up with an unstable environment. Okay, let's say you have 5-10 people chasing after defects, making modifications to the requirements, making modifications to the test cases, etc. Then if you don't have solid configuration management, then you may end up in chaos. And if you have chaos, probably your developers and managers will be frustrated. And unfortunately, you will be wasting time, you'll be wasting money, you will be wasting profit or future investment in your organization. And the software will be delivered late to your customer. So what I'm telling you, okay, is you have to work more intelligently. Okay, working smarter, not faster. Okay, in those cases, slower is faster. Okay, working slower, apparently. Okay? Apparently, you work slower because you are doing reviews at each step of the process, but at the end, you'll end up delivering the product faster because you'll be doing the things right the first time. So let me give you an example of a real company, high tech in the aerospace domain. So here, what I'm showing is roughly at the bottom, similar faces, and on the left side, the percentage of defects. So here, what I show is that 70% of the defects are injected in the requirements and design phase. So 70% of the defects, of the total defects of the projects of that organization are injected before one line of code is written. Okay. Yes, I'm assuming right now that we're working with the cascade model, waterfall, but the same analogy, analogy applies for other type of development, okay, roughly the same. Okay. So most organizations will detect these defects only in testing. Okay, so the defects that this company knows that are injected in the requirements phase, almost 50%. Okay, most organizations that are not doing reviews will detect those defects in the testings. So now you should be able to understand why we wasting 40 to 50% of the budget in software development. But the good news is, if you put in place the correct practices, the correct process, and the reviews, okay, the different peer reviews, the personal reviews, the walkthrough, the inspections, you increase the probability of detecting defects. And here, what I show is they have put in place in their process, they have built in the process software quality assurance practices to detect those defects. And naturally, once they are detected, they're being corrected. Okay, so to the 96% level, 96, 94% level. So the analogy with the water treatment that I showed you before is, in that organization, at each stage of the process, they know that they are injecting defects. So because they're being intelligent, you follow your thought to the end. If you know that you're injecting defects in the requirements, so why not detect them right there using the proper tools, in this case, reviews. And I'll show you later on that the standard that I'll be showing in a few minutes has been designed to help you produce quality products within budget and schedule. And we have built in 29110 the task for you to do the things right the first time. Okay. So let's move to the house of quality. And let's talk about the verification and validation. So verification is, you're asking yourself, are we doing the product right? What I mean by product, at each stage of the process, there is a word product. At the end of requirements, there are the requirements specification. So this is a work product. At the end of the architecture phase, there is the architecture document. This is a work product. At the end of the requirements phase also, or somewhere, okay, you have the test plan, you have the test procedure, and eventually the test cases. So those are work products. So at each stage of the process, you're asking yourself, are we done this product right? And validation is, you're asking yourself, now that we think that we've done each step correctly, how can we make sure that we've done the right product? Okay, the right product. So this is an example here of a waterfall stages with verification stages after the requirements, verification stages after design, and also you have testings, two testing phases, and also you have the validation. So you're validating. Here I should have included another validation stage where you validate the requirements with the customer, and at the end you validate the systems with the customer. Okay. If you do that, it's because you're expecting benefits. Okay, sorry. You don't put in place practices just to waste money and waste time. You put in place practices because there are benefits, and I'll let you read those benefits. And to help you, there is a wide range of V&V techniques. So this is, again, this is your toolbox. This is a toolbox with analysis, modeling, testing, code reading, error seedings, inspections, simulation, prototyping, etc. So those are the toolbox, right? The tools in your toolbox to do verification and validation. So again, depending on the size of the project, the criticality of the project, you will be selecting the right amount of V&V techniques to help you. So if you look at the doghouse, I'm not an expert in the doghouse, but you can see that it makes sense. It has been done right. The product at each stage has been done right. I mean, there have been some requirements to design the doghouse. There is a door, there is a roof, there are walls, and it looks like it's been done correctly. Okay, but the question is it looks like we missed one requirement. Okay, and we missed one requirement. So is this a verification or a validation error? What do you think? Okay. It looks like in one of the requirements, we just forgot the size of the dog. So if we had validated the requirements with the customer, so the owner of that dog, he would have said, oh, my dog is not a Chihuahua. My dog is that big Deadwood dog. So that changed everything. I mean, the process of building the dog house is the same. Okay? Each stage of the process are the same. But at the end, okay, you'll get the correct product for the correct customer, right? So traceability is that thing that makes the links between the different components of the software process. So from the requirements, okay, to high-level design, low-level design, the code units, the testings, and et cetera, et cetera. So you make sure that you have all the requirements linked to all the components of the architecture, and every component of the architecture has some code components, and each code component had one or many tests attached to it, and those tests have been executed and successfully executed. So you make sure that you got everything under control. So let me give you an example of one missing component. So a few years ago, 1999, the Mars Polar lander was launched, and after going around for 50.7 billion kilometers, it was ready to land. So the top part you see are the lander, the parts of the lander that are encapsulated, and the lower part of the picture would show you the lander when it is landed on Mars. And you can see with my red arrow that there are legs. So there are 3 legs, and on each of those legs there was a sensor. It's called a touchdown sensor. In other words, when the leg would touch the ground of Mars, then it will send a signal to the computer, and the computer will do something about this. The problem was, okay, is this lander crashed on Mars, okay, because it looks like, because nobody went there yet, even though this year we'll be sending different missions to Mars. It looks like at about 40 meters from ground, the engine shut down due to some problem about the leg sensors. Okay, and my question to you is 99.9999999% enough, good enough? In this case, no. Okay, why do I have a high number of 9s? So if you measure, if we have you have went through 55.7 million kilometers, and during the last 40 meters, something happened, then you were almost there. You were almost there, very, very close to be there. A few seconds left, and boing, you crashed. Okay? There was some software errors, and you crashed. So the problem was this: is in the systems requirement, there was a requirement saying, please do not use the data from the leg sensor until you reach about 12 meters. Because the way it worked is at about 100 meters or so, the Mars lander will deploy the legs, and for some reason, the sensor will send some signal, okay? And system engineers know about that. So they said, ignore this signal until you reach 12 meters above the surface. And once you reach 12 meters above the surface, at that time, start monitoring the leg sensor. And once you get the signal from the 3-leg sensor, it is the right time to shut off the engine. But this requirement in systems did not appear on the right side, which are the software requirements. So if they had done some traceability, like I explained to you before, okay, they would have discovered that there was one system requirement that was not linked to a software requirement. And because of that line, okay, that line in red on the left side, the project collapsed. The Mars lander collapsed on March. So it means millions, tens of millions of dollars, maybe hundreds of millions of dollars have been wasted because of that little problem. Okay, let's move on. Let's talk about checklist. So checklist is a very useful tool to help us focus. And in our case, when we use the checklist as an example to identify defects, so it helps us focus on a page to help us identify defects. So an example of a checklist. This checklist is applicable to all types of documents, whether you're talking about requirements or a plan. So we want to make sure, if we look at the item 4, GD4, clear, it says information must be clear to all checkers. So it is the place where most people make most mistakes. It is normally clear in the mind of the people that is writing the text, hopefully, but it may become ambiguous, or it may have more than one meaning from the people that will be reading the text. So if someone is writing the requirements, he may be writing things, and it may be interpreted by the architects or by the maintenance people or by the testing people in a different way. So this is one of the places where we find most errors done in many documents. So this is the checklist, very simple, right? Very short, 7 items that will allow you to detect defects in most documents. But to help you focus your mind, there are specific templates or specific checklists, I should say, for specific types of documents. So for the requirement specification, you'll be using the 7 elements of the requirements of the generic checklist, plus the 7 elements of this checklist to help you. I like RS2, traceable, okay? Going back to the Mars lander, if they had done a review of the software requirements using that checklist, they should have been able to say, ho, there is a requirements in system requirement that is not traceable to a software requirements. We have a defect. We have a defect there. Let's fix this defect, okay? Okay, let's move on to another topic, standards. There is a wide, as you can see, within the SC7 subcommittee to which I belong, there is a wide portfolio of standards that address all your needs in software engineering. When I say all your needs, we have the terminology, we have the measurements, we have the requirements, the architecture, the testings, the modeling, the risk, etc., etc., etc. Okay, so we have that. So let me show you a slide that shows you laws of nature that maybe you've studied a few years ago when you were doing some physics or basic chemistry courses. And maybe you recognize the Ohm's law, which allows us to have this conference right now, okay, part of it. Electricity is working from me in Montreal to you in Ecuador, okay? So my question to you is, can you name a law of nature that is a foundation? Foundation, like the Ohm's law is a foundation for electrical engineers, okay? And there are other laws that are foundations for chemical engineers, for mechanical engineers. So what, can you name a law that is a foundation for software engineering? Unfortunately, there are none, unfortunately, because this is one of the big difference between software engineering and other engineering disciplines. And to me, from what I've seen for about 20 years, if we add, okay, we will never have laws of nature to support software engineering, but if we add similar laws of nature that that are used by other engineering discipline, our software engineering discipline will be much better, much more efficient. But unfortunately, we don't have that. We have laws of logic and laws of mathematics. But the good news is we have standards. Okay, I showed you the standards. So what I'm showing you here is the progression of published standards since the 1987 to today. So what it means that we have documented knowledge that has evolved since the 1980s. Okay, we have captured from successful and failed projects lessons to help us build better software and meeting the budgets and schedule of our customer. Okay, so the good news, okay, so the bad news is there are no laws of nature to support software engineering. The good news is we have a wide portfolio of software engineering standards. So for you, those should be the document that you should be using as a foundation to help you develop your software. And the bad news, if I could use this expression, is unfortunately, standards are not equivalent to a law of nature. Law of nature are always right. Okay, the Ohm's law is working exactly the same way in Ecuador as it is working today right here in Montreal. And whether it is -10 here or plus 25 or 30 in your place, it's the same law of nature and works exactly the same way. Unfortunately, software engineering standard cannot give you the warranty, 100% warranty to have a perfect software with meetings, calendar, and schedule. But the good news, it will improve the probability of delivering good software within quality and budget. So your reflex as a software engineers should be to ask yourself when you're developing software, is there in my toolbox a software standard that can help me develop better software or the software required by my customer? Okay, let's move on to the VSCs because we've been talking about the ISO standard 29110. So this is a pyramid of a real Japanese producer of electronic products with different levels of producers or suppliers. And one, I'll let you read this sentence. So one undetected defect in one little component produced by the low-level producer was assembled and integrated into a product and sold all over the world. And to correct this problem, you can see it costed the company $200 million. So my point, as we're going to see and talk about 29110, is there are, as I mentioned before, there are VSCs, very small organizations at each level of this production chain. High level, okay, at the top, there are teams, there are projects, there are departments having up to 25 people. And as you move down, especially if you move down to the very low level, most of them, I would say, are enterprises having up to 25 people. So let's move to the 29110 standard. So I'm going to talk to you about the roadmap, the 4-stage roadmap that we have developed for VSCs. So the subcommittee, as I said, subcommittee 7 is responsible to produce software and system engineering standard. And my working group 24, has been established in 2005 to develop the 29110 series of guides and standards. And the flags and logos that you see are the flags of the countries that are sending experts to work on the 29110. When I say sending, normally we'll be working for the last 15 years, we'd be meeting twice a year in different countries. But for the last few months, we've been meeting with Zoom, like we're doing right now. But it works the same way, okay? Roughly the same way. Okay. So here, the point I want to make, as you can see, there's a wide spectrum of countries, small countries, big countries, developed countries in all the continents, okay, that are working with us to, and also at the bottom, we have a professional society or professional organizations like the IEEE or the system engineering organizations in the world. So back in 2005, when I was elected or selected to become the lead editor of 29110, I made some observation. So the observation were that most standards in those days have not been designed having in mind VSEs. The standards in those days were developed by large people from large organizations to meet the needs of large organizations. In those days, the VSEs had a negative perception about standards because they view standards as being expensive, producing a lot of documentation and looking like a bureaucracy. And for many VSEs, what we found out is their processes were ad hoc and chaotic. What I mean by ad hoc and chaotic, sometimes the process was in the head of the developers, no documented process. And from one project to another, it depended on the people around the place to develop the software. And if those people were leaving, then they were living with their process between their ears, okay? But the products that VSEs are developing are very important to the worldwide economy. So my vision was to see is one day a VSE around the world will be using in their daily activities standards and guides that will help them to develop quality software, that will help them to improve their performance and also their competitiveness. So I decided to participate actively to the development of standards. I decided also to help to accelerate the adoption and implementation of 29110 and to promote the development of educational material. So this is basically what I'm doing today with you, is I'm preaching, if I can use this expression, in the next 15 minutes or so, I'll be preaching about the 29110, the benefits of 29110. So where is 29110 located? Here you can see on the right side, we have on the horizontal axis, on the right side, we have the high ceremony processes, tick process. When I say tick process, many centimeters thick, okay, many centimeters thick, like 5, 6, 7, 8 centimeter thick paper process. And on the left side, you have poor or no process or no documented process. And on the vertical axis, on the top, you see you have the waterfall life cycle model or approach, where no risk. And basically, when I say no, I should say this is a mistake for me. Few risks, because all projects have risks, but few risks. And it is sometimes also large projects work this way because this is the way they've learned to manage large projects, is using the waterfall approach. But if we go down on the spectrum to the bottom, you have iterative approach using, it's a risk-driven iterative approach. And we have position 29110 right in the sweet spot where we have documented process, where you could also work in agile mode, where you could also work using a cascade waterfall approach or iterative approach. So going back to the roadmap, we have developed a 4-stage roadmap, and I will show you what it looks like in a few minutes. So the first stage of the roadmap is for startups or small project having up to 6 person months scale. Okay. Then we have the basic profile guides for the for an organization that has only one project with one team. And then we have the intermediate profile for an organization that has more than one team working on more than one project in parallel. And at the top, we have the advanced profile to help VSEs to become more competitive and grow in the world. Okay, so we have developed this 4-stage roadmap. Okay, you don't have to start at the entry level if you already have some background. Like as an example, since you've been educated as software engineers, my suggestion maybe you could have a look at the entry profile, especially if you want to do a startups. Many students in university decide to team up with 1 or 2 or 3 of their colleagues and do a startup. Then maybe the initial profile is correct. But I would say have a look at the basic profile. It's not much bigger, and I'll show you that in a few seconds. So the entry and the basic guides are available free from ISO, okay? And I'll show you that in a few seconds. So the way that we have designed those 4 stages is like the Russian dolls. So the basic profile is a superset of the entry profile. In other words, if you do the entry profile, once you have stabilized your process, then if you want to move to the basic profile, you just have to add a few tasks. And if you want to move from the basic profile to the intermediate, then you add 1 new process and a few tasks, and same thing for the advanced profile. We have produced a set of documents to help people understand 29110. We have produced an overview document that is roughly explain what I'm telling you today, okay? And we have developed standards, but standard describes to you what you have to do, okay? And VSCs, what they want is guides. Guides will tell you how to do things. So a standard will have a list of things that you have to do. You have to do the requirements. You have to do a plan. You have to manage the changes, okay? But the guide will tell you how to do things. See this, the analogy will be a cookbook, where you want to cook a cake, a chocolate cake. Then you go in the cookbook and you select the chapter about the chocolate cake, and it will give you the recipe. It will list for you the ingredients, the inputs. It will give you the tools that you would need to do that recipe. It will list you the steps and the time it will take to do the process, the preparation time and the cooking time for a cake. And eventually the output is the cake. So see the guides roughly as a cookbook with a recipe. And for any recipe, is after you follow, let's say that you have never done a chocolate cake before, and you look at the recipe and you say, yes, I have all the ingredients. And you look at the task and you say, yes, I can do that, no problem. And you look at the tools and you said, yes, I have all the tools. So let's build a chocolate cake. Same thing when you look at the, let's say the basic profile guide. I would suggest that you use the guide as it is the first time in the first project. And similarly, as when you cook something, after you did it once, you may say, oh, the next time I will add more sugar or more chocolate, or no, I will reduce the amount of chocolate and things like that. Same thing for the guides. Once you've done 1 or 2 projects, you may decide to adapt, do slight modification to the guide, change a few names, because maybe the names in the documents may not match the names that you've used in your company or at your university. But see this as a basic recipe that you will be using, and you'll be improving and building on it, okay? And as I said, they are available in ISO. So the good news is the part 1, the overview document, and as well as the entry and basic profile guide are available in Spanish. Okay? They have been translated partly by ISO or partly by Uruguay or by Mexico or by other countries. Okay, here I'm showing 2 documents from Uruguay, but I know that also Peru has also translated the basic profile for their use in Peru. So let's have a look to the inside of the guide. So a customer knocks at the door of the VSC with a list of functions, a list of needs. Let's call them the statement of work, okay? And then the VSC, the management of the VSC will say, yes, we can do this. This is part of our expertise. We will do this project. Then this will trigger the project management process. And the first thing is you will plan the project, okay? And again, the guide has an activity with a list of tasks that will allow you, like a cookbook, would allow you step by step to build the project plan. And once the plan is approved, then you execute the plan. And then what it means is you're executing the basic software engineering tasks that you already know as a software engineer. And the first activity is in the box on the top is like a kickoff meeting where you want to make sure that everyone on the team knows the process, knows the requirements, knows the tools, knows the roles of each member of the team. And that may take just 5 minutes on a small project, or it may take half an hour for a bigger project, okay? But this is the first stage. And then you can see the different activities, the software requirements analysis, the design, et cetera, et cetera. And as you work, you evaluate yourself according to the plan to see if you're meeting what you have put in the plan. If you have to make corrections, probably maybe you have risks that have now materialized. They're not risk anymore, they're problems that you have to address. And maybe, if you're not lucky, you have unknown risk that you didn't think about that popped up. Okay, someone from the team got sick, someone got COVID, right? Got to the hospital, and you'll be losing that team member for the next 2-3 weeks. So what do? So you have to medicate that risk. And eventually, you're ready to deliver the product to your customer. And we say configuration management, sorry, software configuration. By that we mean the customer asks you naturally that he wants the code, that's for sure. But maybe that customer wants the user manual. Maybe the customer wants an installation manual or other thing. So this is what we call software configuration. And the blocks that I've shown you, the blocks in white, the white blocks, the activities, see them as Lego blocks. For those of you who have played with Legos when you were young, so you can assemble the Lego blocks to make different types of things. See those blocks as Lego blocks. And you can, I've shown you like a waterfall approach for presentation purposes, but you can assemble those blocks using different types of life cycles, like iterative incrementals. You could work with agile approaches and things like that. So let's have a look at the inside of one of those process. So here we have the software implementation process, and we are going to go roughly to the different things to show you what we have. So we have activities. So what's in the middle are the activities. We have entry products, software requirements. We have internal products. By internal products, we mean things that we be developing internally and that will not be delivering to the customer. Unless maybe the customer may say, yes, I would like to see your document called the verification results. When I say document, it could be a paper document or it could be an electronic document, right? It doesn't have to be just paper. And eventually you have the output product, in this case, the software configuration. Now let's have a look at one of the tasks in the requirements analysis. So we have the requirements analysis activity, and the requirements activity is made of a series of tasks. Let's have a look at one of those tasks. So this is the look of the guide. Inside the guide, you will see that we have a list of tables like that. So on the left side, you see the roles. So for this task, the customer and the analyst are involved. And this task, the objective of this task is to validate and obtain approval of the requirement specification. So remember before I talked about validation and verification. So verification, we verify at each step of the process to make sure that we've done the thing right. And validation, we want to check with the customer if we've done the right thing, okay, the right product. And this is exactly what it is. We are asking the customer to review with us the software requirements to make sure that our understanding of the needs of the customer are documented corrected, no ambiguity, nothing is missing. And at the end of that, so this is why we have the input, the requirements specification that have been verified, sorry, and the output will be the results of the validation as well as the requirements specification with a new status. They are now validated. They have been approved by the customer. They have been signed by the customer. So that becomes the baseline. So configuration management wise, after this validation is completed and the customer has approved and signed the requirements the requirement specification, they becomes, let's say, the document, the version 1.0. They become the baseline. And from that point, if for any reason there is a change in the requirements, then we would have to go to a little change process, either internally within the team and the project manager, or externally with the customer to ask him or her for certain changes for some reason. And if the customer or the project manager approve this change, then we'll have a new version, 1.01 or something like that, of the requirement specification. And this is how you manage those changes. So once you have version 1.01 version, then it means that the architecture has to be updated, modified to reflect that new version. It means that those people that are working on the test cases have to also make sure that they are aligned with the new version of the requirement specification. Okay. So for each stage, each document, ISO 29110 will provide you with an example of what should be described in this document. So here we have the validation report, the validation results. And this is typically the list of things that should be included in this document. And the process that is using this document is the soft implementation process. So let's move now from the description of the process to actual cases that have been using the document, the Agile Guide. Actual companies, actual startups, actual VSEs. So the first one is a startup in Peru. I had the opportunity to go to Peru 4 times to go to Lima. And I visited this organization, this startup. So it was created by 2 software engineering students of the University of Lima. And they created that company in 2012. They used a basic profile with an agile mode. And they developed a project of 882 hours, and they had a percentage of rework of 18%. One thing to mention is they obtained a formal certification in 2014. By that I mean, once they've done the projects, they called in an auditor, so someone from outside that has been certified as an auditor to audit 29110. And after a 1-day process or so, the auditor was able to confirm that VSE was using the 29110 as described and was using it in a project, and the auditor was able to see the evidence produced by the project. So the evidence, by evidence, I mean every stage of the process will produce some artifact, some work product. So the auditor was not around when that project was being executed. So maybe the auditor came in 6 and 9 months later after. So the only evidence left are you can interview the people that worked on the project, but you also want to see the evidence produced, the verification results, the architecture, the requirements specification, and things like that, such that the auditor can have a good level of confidence that you followed the process as described in the guide. Okay, so I'm closing the parenthesis here. The second organization is a small cosmetic producer organization with 20 people, but only 1 software developer, okay? Using the entry profile, 12% rework. Another IT startup of 2 people, almost 1,000-hour project using the basic profile with 12.6% rework. And here I want to show you that even in large organizations, there are small teams. So here, this is an organization that is taking care of the production of electricity for 8 million people. And a division of that organization has almost 2,000 people in IT, supporting 2,000 applications. So they have big processes for the big projects, so level 2 or level 3 CMMI processes. But for small teams of 11 people, maybe a level 3 process may not be the right process for small teams. So that small team of 11 people use the basic profile using Scrum on a 1,500-hour project, and they had 9.6% rework. Now, why am I talking about the size of the project and the percentage of rework? It's because of this. Okay, here I show you data from a real company, the percentage of rework as they move through maturity level at the bottom of my slide, from maturity level 1 to maturity level 2, 3, 4, 5, back in the 1980s and 1990s. And what the emphasis I want to show you is the curve. You see that at level 1, they had 41% of rework. And as they move to level 2, they had 18% of rework, and eventually 11, 6, and 5. I didn't show, but maybe I should put it on my next slide, next version, that they had to achieve those objectives or those numbers, they had to do some improvement. Remember that if you want to improve, you have to make modification. You have to invest in tools, in process, in training. So this is what they have done. They have put in place better process, more reviews, and this is how they achieve this percentage of reward. So if you have two companies, one side by side, producing the same product, one is having 40% rework and the other one is having only 18% rework. So this 20% difference means either that you have 20% more profit for the better organization, or you can bid on a project with a lower cost because you know that you are producing software at a lower cost than your competitor, and you can win the contract while the other competitor will not win the contract. Okay, let's move on. So the IT startup in Peru at 18%, the cosmetic organization 12%, the startup 12.6%, and the utility provider at 8.6%. So my point here is by using 29110, you are indeed accelerating the maturity of the VSCs by using proven practices. Instead of reinventing the wheel, instead of starting from scratch, you are using, let me use the expression, the cookbook, right? The recipe, the basic profile guide, and you're following the stage, you're following the process, you're following the activities, and you're producing the documents, you're doing the reviews at the proper place, you're doing the testings and things like that. So no wonder why that instead of starting at a 50% rework, you only have the 10, 12% rework. So you have, in other words, you have a big edge towards your competitors if you're using this. Okay, so just for information, about 21 countries are teaching 29110. This is the country that I know, because maybe there are other countries that I do not know that are teaching 29110, but those are the people, those are the countries with whom I have contacts, or that with whom I teach 29110. So I'll give you an example. In Mexico, I went to Mexico a few times before the pandemic to work with the state of Zacatecas and the Secretary of Economy to help implement 29110 in VSCs. And also the innovation here, the innovation here is also they have implemented 29110 in universities. So in places where they do the end of the curriculum project, we call that the capstone project, they have used the basic profile, and like a real company, they have been certified by the Mexican auditor that flew from Mexico to Zacatecas to audit the software center of the university the same way as they were auditing a real company. And they were issued a certification, formal certification. So 29110 is the first software engineering standard that I know that can be taught successfully to undergraduate and graduate students. And to my knowledge, about 11 software centers from universities of Mexico so far have been certified to the basic profile of ISO 29110. So let's have a look to another country, to Thailand. Thailand has been part of my working group since the beginning, since 2005. And they have decided that 29110 was a very important component of their IT strategy. And they have put together pieces of their strategy for their digital economy country strategy. And for that, they have put together ministries, universities, VSCs, academia, and auditors. And let me give you an example. So in Thailand, at least 10 universities are teaching 29110. And I was invited to teach at the Chiang Mai universities back in 2009, the 29110 and software quality assurance. And the result of that is, so far, they have close to 500 organizations, either private or public. By public, I mean government teams, small teams in a department that are being certified to the basic profile. Going back to Zacatecas, so you can see the evolution from 2017, where they had 8 VSC certified for companies and 4 software engineering centers from universities. And in 2018, they had 7 new organization, and last year or presently, they are working on 5 more, 3 company and 2 university centers. Now, we have developed the standards since 2005, and we have developed the guides, and we think that's good. Okay, we think that's good because at each step of our process, we did verification. We send the documents for review, we get comments, we update the documents. This is a verification, but the validation is how good is it? Is it meeting the needs of the customers? Is it meeting the needs of VSEs? And is it meeting also the needs of academia? So we did a survey in 2018, and it was translated in Spanish by Mirna from Mexico. And so one of the questions we asked them is so what is the overall satisfaction about the implementation of 29110? And as you can see here, 89% of the respondents said they were completely or largely satisfied with the implementation. So they could see visible improvement in productivity, visible improvement in quality, visible improvement in software development, visible improvement in customer satisfaction. So we had the same question to the customer of those VSEs. So we said, are you happy with the software that was delivered to you by a VSE that implemented 29110? As you can see here, almost 80%, 79% of the respondents were completely or largely satisfied with the product and the services obtained from their VSE. And we asked also academia, why are you using 29110? So you see here the spectrum of answers to teach basic software engineering as a good vehicle to teach basic software engineering. And by the way, it is a very, very good vehicle to teach software quality assurance, because as I will show you later on, 29110 encapsulate, and we have embedded software quality assurance practices in the 2 processes of the basic profile. So this is why it is a good vehicle to teach software quality assurance. So you can see the other answers provided there. And so you can see that it has been taught for many years around the world. So if you want to read more, we just published an article a few months ago in the IEEE Computer that describes those achievements. So the benefits, the benefits of 29110, the day-to-day benefits, I'd like to read those. The last bullet, we talk about the way of working here. In other words, you have, let's say you have adopted the basic profile. After doing 2-3 projects, you have adapted the guide, the terminology to fit the needs of your domain. Let's say you're working in the bank environment or financial environment, so maybe you have different titles for the different documents. Or if you're working in other types of environment, then you have adjusted the guides. And eventually that becomes the way to work in your organization. So when you hire a new employee, okay, since we don't do telepathy, you cannot transfer automatically the knowledge in your brain to your new employee, but you can show them and you can walk through with the new employee the process, such that the learning curve of that employee is accelerated. He doesn't have to learn on the spot what you're doing. He can read the process, and you can tell to this employee, your role will be the role of the analyst. And so in this process, you will see all the places in the process where you are involved as the analyst for the tasks, okay? The next slides, we talk about the business benefits, because when you adopt a standard, just for the fun of adopting a standard, you have to have benefits. For every $1 invested, you have to have at least $1 saved. And ideally, you would like to have $2 saved, $3 saved, $5 saved for every $1 that you invested. So instead of reinventing the wheel, you're learning from the mistakes of other people, and you're learning from the good things that other people have done in the past, because those bad things, we've learned from them, and we have captured also the good things, and those have been captured in the standard, in the 29110 standard. Okay? So the portfolio of 29110 is wide. I won't talk about all of them. I want to talk about those two at the bottom. The Agile Guide, we have two people from Mexico that are acting as co-editor, and they have produced a first draft of the guide last year. It went through a cycle of review within the 37, 38 members of countries that are members of SC7, and we got comments back, and at the last meeting in December, the comments were reviewed, were addressed, and your Professor Sandra participated to this meeting with the Working Group 24, and she contributed to the meeting. So the guide now is being finalized because the editor are now implementing the comments from the country, comments that have been approved from the different countries, and within the next 2-3 weeks, they should send me the final version of the Agile Guide. I will do a last final review of the Agile Guide, and then I will recommend that this guide will be published by ISO. Then it will be sent to ISO in Geneva, and in a few months it will be published on the ISO website and it will be distributed. So same thing, we should be working on a DevOps guide. We have not started the guide yet. We have someone from Australia volunteered to develop the DevOps guide. So we'll be talking with this expert in a few weeks to kick off this guide. But as you can see, about the software engineering on the left side and the system engineering on the right side, the 4 profiles for the software and system engineering have been finalized, okay? And the last profile of system engineering should be published in a few months. So we have the complete portfolio almost done. And also recently, we've been working in the space domain. So 6 or 7 space agencies around the world have identified the basic profile as a foundation to help them and help their suppliers in developing better quality. So they have decided to adopt the basic profile and to add specific practices that are specific to the space domain, such that it becomes a specific guide for the space domain. So the requirements or the specification for the new guide are almost approved. In a few weeks, we should be seeing the document, the one on the left side, being published by ISO, and we already have a guide, a draft of the guide, the one on the right side that is on my computer, and I'm working with the editor in Spain on this one, and hopefully we should have this guide finalized in 2021 to be published at the end of 2021 or early 2022. So if you want to know more, you can consult my website at the university at ATS. It is available in French, English, and some Spanish. So quality assurance is what you need to develop a software product with budget and schedule. It's a lot of practices, okay? And the analogy with the clock mechanism that you see is that practices have to be implemented serially and in parallel. So like a clock, I think some gears move together and some gear move only once an hour, okay? Or one every minute. So same thing in software engineering. Some practices are implemented all along and some practices are implemented at specific places. So going back to the House of Quality, the links between 29110 and the House of Quality. So what is in red is what has been embedded in 29110, either directly or indirectly, okay? So naturally, we talk about software quality assurance, we talk about configuration management. Remember traceability, issue with the Mars rover, we have traceability tasks within 29110. You do some measurements, you do risk validation, this risk management, and you also do some verification and validation activities. We don't ask you to produce a quality assurance plan, but the quality assurance is built in, as I said, by putting in place in the project management process and in the software development process, we have put in place quality assurance practices. So they are built in, so you won't see a quality assurance process. You will see just two processes in the entry and basic profile. So those are being documented in the two books that I wrote with my colleague a few years ago. When I say a few years ago, I just realized it's 10 years ago now. So it's 700, almost 800 page, two books published 10 years ago. And 3 years ago, 2018, the book in English. And I was told by Sandra yesterday that this is the book that you're using in your software quality assurance courses. And I've learned a few weeks ago that it is being translated in Chinese in 2021 to be published next year. So that message tells me, because originally we wrote it in French, and then there were some interest from the IEEE Computer Press to have our textbook translated in English, because it was quite different from other software quality assurance textbook. Because we have, as you can, maybe if you look at the book, we have a lot of examples, very practical things. So maybe this is the reason why it's been translated in Chinese. And we should have a Spanish translation initiated in 2021 also. So going back to those questions that I asked you an hour or so before. So if you can provide those process measures, maybe you can claim that you're really managing your software development. And if you can provide those product measures, maybe you can really claim that you're producing quality software, okay? So going back to the 1968 conference, let you read what I think is happening today. So like the medical environment that I showed you about hand washing, we still have in software development, software engineering, many organizations all over the world that looks like they have not discovered the advantage of using proven practices. So in conclusion, there is a wide spectrum of proven software quality assurance practices, okay, available to facilitate the development of quality software products. Software quality assurance can help you increase the confidence. Okay, software quality assurance cannot give you 100% confidence. No standard can give, no software engineering standard can give you this. Okay, but it will largely increase the level of confidence that you'll be delivering quality products within budget and schedule. And 29110 has been developed specifically, and I stress that. The team that I've been working with for the last 15 years, we have been working on just that with people working in VSEs, developing things specifically for organizations having up to 25 people that develop either systems having software and hardware components or software products. And we have developed a roadmap, 4-stage roadmap, that will help VSEs to move from startups to grown-ups. Okay. So before we leave, let you show you what is happening also. The sad part, I would say, the author of a column in the IEEE Software magazine, I've been running that column for 10 years. And after 10 years, they said, okay, let's step back and let's see what were the real impact of our of software in the community in general. So one of the things they found out is, unfortunately, software developers, they jump from one fad to another without learning from the previous one. So by fad, I mean a new tool, a new language, a new methodology that has been promoted by a company to make money, and they jump on that without having mastered, without having learned in depth and applied in depth the previous methodology, the previous tool, or the previous programming language. I'm not saying that you should not move and evolve. I'm not saying that, but it looks like we're jumping. Eh? We're jumping from one fad to another. and we cannot call ourselves an engineering discipline unless we systematically learn from our mistakes. And I stress the word systematically, from our mistakes, okay? Because we will be making mistakes for the next 100 years, but we have to learn from them. So it means that after a project is completed, we should be doing a little session of lessons learned, that, like it is explained in my book. This is very important. We have to step back and say, okay, what have we done good, such that we repeat those good things in the next project, and what can we improve for the next project? We still missed a few errors that have been injected in our product. So can we improve the checklist? Can we improve our tool? Can we improve our template such that this mistake will not happen anymore in the next product? Okay, so we have to systematically learn. Other engineering disciplines like civil and mechanical engineering have been able to improve, let's say, the reliability and other quality characteristics of their product for the last decades. As an example, the jet engine. Okay? From the first generation of jet engine produced, maybe I forgot, I'm not a jet engine expert, but 40 years ago or so, to the most recent jet engine that have been produced for the new generation of aircraft. And even now, they're working on hydrogen jet engines and other things. So they have been constantly improving the reliability and other performances of those engines. But by learning from their mistakes and measuring, and unfortunately, it looks like software people have an aversion to measurement. I don't know why, but I have an idea, and I'll show you that in a few seconds. But if we don't measure, we will not improve, okay? Measure is the data that you need, like Semmelweis, if you remember Semmelweis. But when you do reviews, when you do software reviews, you will be able to measure where you have injected defects, where you have detected that defect, and how much effort it took to correct that defect, and what is the quality of the software delivered to the customer. And eventually, with this data, you'll be able to step back and say, okay, how can we improve the process, let's say, of the requirements? How can we improve the quality of the requirements such that we don't have 17, 18, 20% defects in the process of working with the requirements? But with data, okay, you have a stronger position, okay? If people do not agree with you, you can say, I have data to prove the opposite. You have an opinion. If you come up with data that contradicts my data, then we will have a serious discussion. But I have data to support my hypothesis. You have an opinion, but my data beats your opinion. Sorry, okay? That's life. So again, okay, if you don't change anything, you cannot expect the situation to improve. So we have to learn from mistakes, and we have to measure, okay, constantly measure. So question to you, to think about, to talk about, to discuss amongst yourself and with your professor is, why do a large number of software organizations either ignore the existence or don't use software practices that have been available since the 1970s? Okay, why? And I'm sure that you know organizations, you know companies, you know some projects that have been working from what we call the seat of the pant. So instead of using proven practices, they're just working like artists. Okay? So why are so many software people not working smarter and not using proven practices? So the first question was about the organization level, and the next question is about the individual level. So why are you, maybe you are, I don't know, because I don't know you, but with the trips I made around the world, I've been around the world so many times during the last 15, 20 years, meeting people, meeting students, meeting professors, meeting people in industry, meeting government organization, that I can see that, I can say that people are not working smarter. Okay? They're working harder, but not smarter. They want to go faster, but they're not working smarter. And my hypothesis is maybe, is it because software developers and software managers have a big ego? Okay, because they say, "Oh, I am a software engineer. I don't need to follow a process. Oh, I am a trained software engineer. I don't need to follow a checklist and use a checklist. I'm better than that. No, I've got a bachelor degree or master's degree in software engineering. I don't make mistakes." Sorry, I have a bad news for you. You will be making mistakes. So since you know that you will be making mistakes for the rest of your life, so why don't you react accordingly? Okay? Why don't you use the scientific approach demonstrated by Semmelweis? Okay, measure yourself. Okay, if your organization is not doing reviews or mandating reviews, why don't you do it personally? Because there is a personal review that is available. It's a very simple review to do, and you do the review on your own documents. Okay, at least you improve the quality of your own documents if the rest of the organization doesn't care about that. But my point to you also, and this is what I've told my students many times, is you're young, so you have in front of you 40, 50 years of career. So are you willing to invest in an organization that do not have a process, that have a, let's say, a level 1 process? Or would you prefer, or should you be working in an organization like that has a mature process, like let's say at least a level 2 process, or level 3, or the equivalent level 2 or level 3 process, that are using proven software engineering standard, that have a documented process, that are implementing software quality assurance practices, that are training their new employees, that are constantly improving their process and their training and the tools and the checklists. Wouldn't you prefer to work in this organization? Because if you work in this organization, you will be improving yourself. So your own value, if I could use this expression, your own value in the market will improve much more if you work in such an organization than if you work in an artist organization where they don't care about process, they don't care about standard, they don't care about anything. They just ask you to do that damn code, produce that damn code such that we deliver that damn code to the customer Friday, and the rest we don't care. So it's up to you to select which way you want to go. And this is why at ETS, those 3 internships are eyes opening to students, because they can see by working 4 months in one organization, they can see, because they are working as apprentice, they can see the culture of organization, they can see because they're using the process organization, they can see if they would like to invest their career in that organization, or on the contrary, if they would run away from that organization, maybe from outside. It looks very nice. They have very nice brochure, and they will give you a cappuccino, and they have a bar where every morning you will have a breakfast. But if you look inside, maybe the culture or the value of that organization may not match your own value or your own career objectives. So look at that when you look for an organization, because again, your value will improve if you go in, I would say, more mature organization, because you will be carrying this knowledge from one organization to another during the next 40 to 50 years of your career. So this is all I have to say. So now we can move to question period. I will ask Sandra to open the discussion. Okay.
Yes. Thank you very much, Claude.
So I'm open for questions. We have, I don't know how much time. Oh, maybe how much time do we have, Sandra?
Actually, you talked 2 hours in a row, so. But that's good. Thank you very much. You have good energy this morning, I guess.
Yeah, it's because it's earlier in the day, maybe.
I know. But anyways, I guess we can have at least 1 or 2 questions. If you can stop sharing your screen, and maybe the students can show their faces also. Chicos, si pueden por favor poner sus cámaras para que Claude nos conozca. So Claude, you can see the faces behind the screens. And if anyone can want to make a comment or a question, please do so. Si quieren hacer alguna pregunta, lo pueden hacer, sea en español o en inglés, o en francés. Also, you take French, right?
Oh, yes, yes, I prefer French.
I know.
I prefer French. I've tried to practice Chinese when I went to China a few years ago, but I'm not good at Chinese. So I'll prefer, let's say today I'll prefer English.
Yeah.
But if you want to ask it in Spanish, at least in Spanish, and Sandra will translate it for me.
Yeah.
Do not hesitate.
And how is your Spanish, Claude?
The thing is this, I want you to invest time and energy in learning Spanish, but the thing is here in Montreal or where I live, we speak French. So yeah. I don't have opportunity to practice. And unfortunately for the last month, for last year, I was not able to travel. So the thing, as you know, if you want to improve, you got to practice. And if you don't practice, you just lose. So I was supposed to go this year. I was supposed to go to a tour of Colombia. I was supposed to go in Mexico in 3-4 cities. I was supposed to go in Chile and Peru. I had a series of meetings organized, and due to COVID, everything's collapsed. And yeah. Unfortunately, I'm not sure that even next fall, we'll be able to go around and do that. So yes.
Yeah, that's right. But anyways, for the future, please keep Ecuador in mind.
Yes,
yeah.
yes.
It will be a pleasure to have you here in my university and to show you around. So
it will be a pleasure for me to go. It will be a pleasure to go to see you in 3 dimensions and not only on
exactly, not just on the screen. I know.
Yes.
So please, guys, if you have any question or comment, now is the moment before we finish this class. Ismael, please go ahead.
So first of all, welcome to the National Polytechnic School. It has been a very enriching talk. So well, Ryan and I have a very small startup where we develop simple software, you know, such as web pages or apps for Google Play. But as you said, the standards are not intended for small organizations. So the question...
Just one thing, the standard that were around in the 2005 period when we started our working group, yes. So 29110 addresses that issue.
Okay. Yes. So we wanted to adopt the 29110 entry profile around agile methodologies. Do you think it is necessary to integrate more personnel to the staff, or and do you think the benefits are significant for a very such a small organization, and of course in a developing country like Ecuador?
So the question, if I understand your question correctly, it's a business question. Yes. The technical question is, for a startup, the entry profile is a good approach. Now, maybe you could have a look at the basic profile, because as you know, the basic profile is introducing a few additional practices, but it's not a Bible. So it's not one or the other. You may say, okay, we're not ready for the full basic profile, but maybe there are a few things in the basic profile that we can import in our entry profile guide. Let's say that you want to do traceability. It's not in the entry profile, but it's in the basic. So maybe you could say, okay, let's put traceability in our entry profile and we'll be happy. So then business side, you have to do a product, sell a product, and make money, okay? Because at the end of the day, or at the end of the week, you have to pay. Maybe when you do a startup, you don't have a pay. You have to beg and steal, okay, from your parents some money to survive. But that's okay. That's how startups get startups. But eventually, money will come in, and then you will have to make decisions about what you will be doing with this money. Hiring new people. But if you want, it means if you want to hire new people, it means that you don't have all the skill set that you need for the type of product you're developing, or you don't have enough in your startups to enough people to do all the things. So I cannot give advice about the business, because each business is different. Because I would say is this: if you apply the entry profile and you're doing a good enough product such that you have customer buying it and you're making money, then maybe you have the recipe for success. And slowly you would be improving a step at a time. Okay, not drastic step, but a step at a time, and maybe importing from the basic profile practices in your entry profile guide, or you may decide as owner of the startup to do a jump and to jump from the entry to the basic profile. Now, one business decision, and I don't know if you can do it in Ecuador, but in Peru they could do it, is you could get some certification. It doesn't have to be a formal governmental certification. It could be a third-party auditor. Okay, it could be someone that is not part of your organization that has software engineering expertise and can review your process to say, yes, you're following the, let's say, the entry profile. It can review the documentation and say, yes, you have followed the process, and it can give you a letter confirming that after reviewing the process and reviewing the artifacts and interviewing the people in your VSE, that you are complying to the 29110, and that letter could be then be used to talk to potential customers, talk to partners, talk to future employees to say, hey, this is how we work, and we have an auditor that confirmed to us that we're working the correct way. You could go to a bank, maybe because you need some investment to do something, to buy things, to buy tools. Maybe you can go to a bank with this letter and saying, hey, we are software engineering graduates, we have implementing an ISO standard, and we had a third-party auditor. And based on that, we are reducing the risk of you to invest in my organization, such that the banker will look at it, or an investor. It could be a risk capital. I don't know in Ecuador, but in many countries, there are people that have a lot of money, okay, to invest. It's called risk capital. And let me open a parenthesis here. When we started to work in Thailand, we were invited to go in Thailand 2 times, all expenses paid. When I say all expenses paid, I flew from Montreal to Bangkok in business class. I went to 5-star hotel for 1 week, and we did that 2 times. We were 10 people that were invited to Bangkok. And so we asked the question and said, why are you paying all that money? And then we had a dinner with the capital risk manager. And he said, we have many millions of dollars to invest in IT companies. We know that idea or that product, we can make money out of it. So this we know about that. But what we don't know is, we don't know if that VSC or that startup will be able to deliver a quality product within the time and budget. Because we're willing to invest money, but we don't want to waste our money. So he said, we, the investor, the reason why we're inviting you to come to Bangkok is we want you to accelerate the development of 29110, such that when it is published, we can turn around to the VSE and you say, you want money from us, go and get certified. Because if you get certified, it will give me, the investor, a level of confidence that your product will be delivered within the budget and the schedule. And me, as an investor, I'll be making money. So you see the game, it's like a tango. Okay, I don't know if you learn tango. I've took a few tango lessons. It takes 2 to tango. You cannot dance tango together alone. So it takes the risk, the capital to be invested, and it takes the VSE to produce the product for that investor to make money. So this is maybe the biggest business decision for you, is to look for a risk capital, look for partners. Maybe there is okay, I'm opening another parenthesis. In Thailand, they said they have thousands of startups. The problem is, if they want to work on a bigger project, they don't have all the expertise within one startup. But if they team up with another VSE, then they could have complementary skills. So the objective of 29110 in Thailand was to certify hundreds of VSEs such that they can work on bigger products, bigger projects. So if they have competence in one area, another VSE has competence in another area, if they work together, because they use the same standard, they speak the same language, they have the same process, they're much more efficient to work as partners. So maybe your option would be also to find other people that have been trained to use 29110 and become your partners in your business. That's another solution. Okay. So I don't know if I answered your question.
Yes, that's my question. Thank you.
Okay.
Yes, thank you. Thank you very much, Claude. This is all the time we have for today, but I'm going to ask the students to write questions for you so you can answer them later on. Yes.
Okay,
so
fine.
That will be all for today. Thank you very much again, and I hope to see you soon. And thank you very much also, you guys, for being here. So
thank you for inviting me. Bye-bye.
Bye-bye.
Bye.
Hasta luego con todos. Por favor, revisen el aula virtual para la tarea de esta semana. En el aula virtual les voy a colocar. Entonces, gracias por quedarse hasta el último y conversamos el viernes, ¿ya? Hasta luego.
¿La tarea es para este viernes o para la próxima semana?
Esta tarea va a ser chiquita, solo de Klaus. Unas 3 preguntitas en el foro antes de que se nos olvide la conferencia. Ya les publico más tardecito y les aviso. Esa es de entre hoy y el viernes. Y la otra sí está pendiente, la del laboratorio. Eso sería todo. Listo, chicos. Gracias y que tengan buen provecho. Hablamos el viernes entonces. Hasta luego.
Gracias, profesor.